How's it going, AP Stats students? Shane here from Fiveable to cover our next session around z-scores. So take a minute, gather your belongings, and we'll dive into z-scores, which is a huge topic in statistics today. So follow along with me on the PowerPoint. Feel free to ask any question below. Looks like we don't have anyone yet, but as you come in, be sure to ask some questions and we'll get that going. So we'll start here with our session. Let me hide this. Get this going. Let's do that. All right. So we're going to cover standardized score, aka z-score. For some reason, I got some flies in my classroom, so you might see me swatting. Ignore that. Don't worry about that. And all right, let's dive into it. So as always, I'm going live on Thursdays at 5 p.m. Eastern or 5 p.m. Pacific Standard Time, and I will be going live 8 p.m. Eastern Standard Time. The first major topics that we covered: exploring data, which is kind of that first unit where you're talking when you're looking at data. What are some important pieces of information to gather from it? How do we present it? Designing studies. So we'll get into that a little bit later. And then the normal distribution, which is what we're going over now. As always, you're going to get some exam tips from me, some multiple choice and free response questions, some calculator tips, most importantly, and just a lot of other stuff that's going to help you get a 5 on the AP Stats exam. So we're going to talk about z-score, which is standardized scores. Now, most of you are probably in this unit already or just about finishing with it. So it's good to get kind of a review of what's going on. So first of all, what are we going to cover today? We're going to calculate the z-score. Pretty basic, but definitely 1 or 2 questions on the AP exam will be about this. Interpreting the z-score. So what does it actually mean that we get this number? How do we interpret it? Finding percentile using the z-score. So now that we have this z-score, what can we actually use it for? And we're going to do that using a table and calculator. I prefer the calculator, but a lot of students like having that physical table, which looks a little bit like this. You've probably seen it before. It's in your textbook. It'll be on your AP exam. So just in case, let's say your calculator batteries go out, you can find percentiles using z-score and your table. We're also going to be finding values using percentiles. So if they ask you what would the weight of a male grizzly bear be at the 40th percentile, you can then give that to them. And then finding percentile between 2 scores. So a lot of the time on the AP exam, they're going to ask you, hey, what percentage of the data falls in between these 2 numbers? So we got to make sure we know how to do that. I just had a bunch of students come in today and ask about it. All right, let's dive into it. So exactly what is z-score? So z-score is right there. I'm going to take a swig of my water. So z-score tells us how many standard deviations from the mean an observation falls and in what direction. So once again, it tells us from the average, how far away is it, and in what direction. So here is the formula for it. You take your data point and you subtract the average, also known as the mean, and divide it by the standard deviation. Here's the formula in symbols. Don't forget that if you have a sample, you're not going to use mu, you're going to use x bar. Here's what it looks like. It looks, we have to have a normal curve. Your average is in the middle in green. And then in red, you have 1 standard deviation away from your average. So you have 1 standard deviation below and 1 standard deviation above. And we can see that there. That location is 1 standard deviation below the mean. And over here, we have 1 standard deviation above the mean. So that's standard deviation in a nutshell. There's a special rule for normal distributions that we want to go by, and it's called the empirical rule. It's also known as the 86, 95, 99.7 rule. And so what that says is if you're at your average, if you go out 1 standard deviation in each direction, you're going to cover about 68% of the data. So again, since we're going in each direction, one way is going to be about 34%, and the other side is going to be 34%, which gives you about 68% of the data. That's the middle 68% of the data. If you go out another standard deviation, you're going to cover 95% of the data. So we had 68 when we did this. Then when you go out another standard deviation, you cover 13.6 on this side and 13.6 on this side, which leaves us with very little data left. If we go out another standard deviation, remember so the 2 standard deviation out covers 95%, which means there's 5% left over. Remember, it's spread out on 2 tails, right? So there's 2.5 over here and 2.5 over here, or 2.1. It's all rounded, really. But if we go out 3 standard deviations, we're only left with about 0.3% of the data. So we cover just about every data point. And that's why you see the end of the tails being so small, right? Because normal curves, we measure the area under the curve. So the area under the curve for 2 standard deviations out is 68. Sorry, 1 standard deviation out in each direction is 68. 2 standard deviations out is 95. And finally, 3 is 99.7. That's just a good trick to know. It'll give you, maybe save you a little bit of time on the AP questions that they ask, but definitely a good rule to know. And they're probably going to ask it on your AP exam in your class anyways. So good to know that. Great. Now let's actually work on a z-score topic. We're going to actually calculate z-scores in our next slide. So here we go, calculating and interpreting. So here is a AP question that I changed a little bit, but it says the weight of an adult male grizzly living in the wild in the continental United States is approximately normal. So we have that normal curve with a mean of 500 and a standard deviation of 50. We want to know, what would the z-score be for a male grizzly weighing 530 pounds? So I'm going to go to my document camera so I can show you how to do this one. Okay, so we want to know if it is normally distributed. So we know it looks like that with an average. And I always encourage my students to draw out the normal distribution first so you get a good idea of what it actually looks like and what we're trying to find. So we have the average here, which is going to be 500. Let me double check that. Oops. How do we get out of this? Yep, so grizzly weighs 500 with a standard deviation of 50. Let's go back here. And we want to know if someone got a 530, what would be the z-score for that? So we want to find, again, here's the formula for z-score, and I always encourage my students to write out the formula. And then you just kind of plug and chug. So this is where algebra plays a big part in statistics. So we don't know our z-score, so I'm going to keep that here. We know our data point is 530. We know our average is 500. And we know our standard deviation is going to be 50. So like I said before, then you just calculate it. 500 minus, or 530 minus 500 gives me 30. Divided by 50 equals my z-score. So I get a z-score of 3/5 or 0.6. pretty straightforward. It will get more complicated, and I have some questions to help us out with that. But that is essentially calculating z-score. Now let's see our... So we got the z-score, which is 0.6. Now you're probably going to be asked to interpret it. So what does that mean? Well, if an adult male grizzly bear who weighs 530 pounds is 0.6 standard deviations away from the mean, and in this case, they're above the mean. They're above the mean. Oops. Oh, a full standard deviation would have been 50 pounds. So 550 would have been a full standard deviation out. But it was 530, so we shouldn't get 1. You should get something between 0 and 1. We got 0.6, so that makes sense. So again, to interpret it, an adult male grizzly bear who weighs 530 pounds is 0.6 standard deviations above the mean. If you got a negative standard deviation, that would be below the mean. So make sure you know that negative z-scores are below, positive z-scores are above. And as you start filtering in, please use that ask a question feature. That's really going to help me tailor this session to what you need, right? Depending on where you are in your unit. Think of me as your live tutor. Ask me questions. I'm going to stop my PowerPoint to answer any questions that you have. Okay, so now how do we find the percentile using z-score? That's an important part. So we want to know, hey, that grizzly bear that we just found out, what's their percentile? We got to use what's called the z-score table. Now, I would say 99.9% of you have this in the front or back of your textbook. I always keep copies in my class just because you kind of never know when you're going to need them, and the textbooks are big and heavy. If you Google z-score table, you're going to grab one of these. I would print it out, keep it in your binder. That way you don't always have to have your textbook around. You could save it as a picture on your phone, and that way you can kind of zoom in, which helps a lot. But sometimes you don't have storage on your phone, so the printed out physical copy is kind of best. So you're going to need a table unless you want to use your calculator, but I'll show you how to use your calculator in a minute. Some people like to use the table, so let's keep the table out. So again, if the weight of an adult male grizzly bear living in the wild of the continental United States is approximately normal distributed, so we know it's that normal curve, has an average of 550 and a standard deviation of 50, what percentile would be a male grizzly bear weighing about 530? So we already know that the z-score for that is 0.6. So if you look on the side of the table, you're going to see the z-scores. So this tells you the ones and the tenths place. Then if you go to the right, you're going to see the hundredths place. So our z-score was 0.6. So we want to find that. So there's 0.6. There's 0.0. So our z-score is going to be right there. It's kind of faint, but you can see it right there. So our percentile is 0.7257. So what does that mean? Well, that means that a bear weighing 530 pounds is in the 72nd percentile. And we covered percentile last video, so go back and check out the last video to understand exactly what percentile is. But essentially, it means 72.5% of the data falls below that score. So 72.5% of male grizzly bears weigh less than 530 pounds. Now, that's all handy, but I like to use the calculator because the calculator saves us lots of time. So let's try it with the calculator. And this, again, is when you do not need your table, which is really, really nice. And just, does everyone here have a TI 83 or 4? If you could just comment in there saying, yes, I have a TI 84. No, I don't. If you do, here's what you want to do. You want to hit the second button, then you want to hit vars, and you want to go down to number 2, where it says normal CDF. Then you're going to type this in. So don't type in lower or upper number, but lower number is going to be the lowest value that you want to capture. Upper value is going to be the highest number that you want to capture. Then you type in the mean and the standard deviation. So for this score, or for this problem, we would type in normal CDF, comma, negative 99999, just a really, really small number. That way we make sure we capture everything on the tail. So as those normal curves come out on the tail, we want to capture everything there. Then we type in the highest, which is 530, then 500, then 50. And when you do all that, you'll get around 0.7257. Okay, and let me show you what that looks like on the calculator. So once again, we're trying to find how much data falls below this value. So we're going to go to our calculator, turn it on. We're going to hit that second button right there, and then the vars button right there. Actually, let me clear everything first. So second vars, we're going to go down to normal CDF. The low value, like I said before, we want to go extremely low because we don't want to cut it off, let's say here, and miss all that data. We want to capture everything. So we go normal CDF, negative 9999, comma, which we said was 500, or I'm sorry, the high, which we said was 530, the average, which was 500, and the standard deviation, which was 50. Hit enter. Look at that. We get exactly what we got on the chart, and we saved a lot of time rather than looking at this chart. Chart's good. It gives you a visual, but I prefer the calculator, and on the AP exam, you're going to want to save as much time as you can so you can go back and review some of those problems that maybe you were stuck on. All right, so that was the table. That was the calculator for finding percentiles of a given number. So now that we did that, let's dive into our next part. Like I said before, there are multiple ways to ask these types of questions, so it's important that we practice them. So here we have an actual AP problem, one that you saw, and we're going to do it together. And I have that right here. So the weight of an adult male grizzly bear living in the wild in the continental United States is approximately normal distributed with a mean of 500 and a standard deviation of 50. The weight of adult female grizzly bears is approximately normal with a mean of 300 and a standard deviation of 400. Approximately what would be the weight of a female grizzly bear with the same standardized score as a male grizzly bear that weighs 530? So this is, again, is one of those questions that has to do with z-score, but it's just a little bit more complex, right? The AP test is not going to straight up ask you, what's the z-score for this value? They kind of want you to break it down and be a little bit more complex than just that. So here's how we do it. We have two distributions here. So first we have our male distribution. As you draw these more and more, you'll get better at making them symmetrical. I'm okay. I'd love to improve that. But we have an average for the males of 500 with a standard deviation of 50. And the score that we're looking for is 530. Then we have the female distribution. The female distribution has an average of 300 and a standard deviation of 40. This is an actual AP problem. I believe it was from 2012 or 2011. So again, this is an actual AP problem. And we want to know, hey, what score would give us the same z-score as this, right? So what weight would give us the same score here as here? So what we have to do is, again, we have to find that z-score. So we actually already did the z-score for this in our last problem. That's why I put it there. But we'll do it again real quick. So there's the formula. Z equals x, which is 530, minus the average, which is 500, divided by 50, which becomes 30 over 50, which becomes 0.6. So here's the hard part. Now, we want to take that z-score and use it for our female side. Now remember, the female, again, the same z-score, but this time, the unknown is this part right here. This is what we're trying to find. Everything else we do know, though. We know the z-score is going to be the same as this one over here, so 0.6. We don't know what weight is going to get us a z-score of 0.6. We subtract our average, which is not 500 because that was for the male. It's going to be 300 because that's for the female. And then we divide it by our standard deviation. Oops. And then, again, here is where algebra plays a big part in AP Stats. There's not a lot of other math that comes into AP Stat. Like, you're not going to do pre-calculus. You're not going to do calculus. It's basic algebra, and then obviously a lot of statistics. So to undo division, you multiply, because we want to get x by itself. So we multiply both sides by 40. Those cancel, which is good. That's what I wanted. 40 times 0.6. I'll use the calculator for that. Gives me 24. Equals x minus 300. Then to undo subtraction, I add 300. I add 300. And what we end up getting is 324 equals x. So that means a female grizzly bear weighing 324 pounds will have a z-score of 0.6. So this right here is going to be 324. So my answer is B. So again, it is kind of straightforward z-score, but it's a little bit different in how they apply it to the problem. All right, let's dive into our next topic. Again, we could do 2 weeks on z-score because of how complex it can be. But here's like the basic things that you need to be successful in the AP exam. So we covered calculating z-score. We covered interpreting. We found percentiles using the z-score, using the table and the calculator. We found values, or we haven't found values using percentiles left. And we still have to find percentile between two values. So what if the question was asked, the weight of an adult male grizzly, again, all that stuff, again, we already talked about, same situation. But if we wanted to know, what would the weight of an adult male grizzly be at the 10th percentile? So if we wanted to figure out what the 10th percentile of this distribution was, how would we go about doing that? So again, we use our z-table. We can do this 2 ways. One way is using the table. The other is the calculator. I will show you the calculator in a little bit. So first thing we have to do, find our percentile. So in the middle of this paper gives you all the percentiles of the normal distribution. So what we want to do is find the 10th percentile. So this right here is going to be the closest to 10%. It's not going to be exact. It's really, really tough for a table to be exact. The calculator will be exact. The table won't be. But on the AP exam, they're okay with you using the table, so you don't have to be exactly on. After you find the percentile, so that 10% down there, then you want to find what z-score is associated with that. So again, here is your z-score, the ones and the tenths. Over here is the hundredths place. So we have a z-score. Well, here's the steps again. Find the percentile in the middle of the table. This might be something to screenshot in a minute. Find the corresponding z-score. So we found negative 1.28. Plug in the z-score into the formula without the value and solve for your value. So here's an example. We plugged in our z-score, and that actually should be negative, right? X minus 500 divided by 50. So after you solve all that, you should get about 436. And let me show you on my paper. So we had our normal distribution. Again, I like my students to draw this out with an average of 500 and a standard deviation of 50. We want to know, hey, what is the value if this is 10%, right? What would be the weight of the grizzly bear? So again, using our chart, we looked up 10, and it looked like it was about right there, which ended up being a z-score of negative 1.28. So again, we always want to write our formula. Using our formula, z equals x minus average divided by standard deviation. As you write it, you'll start to memorize it, and then you won't need to write it anymore, just like any other formula. So we plug in our new z-score, which was negative 1.28. That tells us how many standard deviations away from our average the 10th percentile will be. Equals what data point minus your average divided by your standard deviation. And then again, we want to undo division because we want to get this by itself. So we multiply by 50 over 1, multiply by 50 over 1. So negative 1.28 times 50 is going to get me negative 64 equals x minus 500. I got to bring this 500 over, so I add 500 to both sides. So we get our value equaling 500 minus 64, which gives me 436. So that tells me that if a bear, a male grizzly bear, weighs 436 pounds, they're going to be in the 10th percentile. So the answer to that question is 436. Just like our last problem, though, you don't need to have your z-table to get it done. You can actually use the calculator, and I'll show you how to do that. Let's click through this. Again, this is how we find it using our table. Here's how we do it using our calculator. Here's our problem. So you're going to hit second, vars. This time you're going to go down to number 3, inverse norm. Notice both the calculator functions said norm, right? Like normal distribution. So after you type this in, following the parentheses, you're going to put percentile. So in this case, we wanted the 10th percentile. You're going to put the average, then you're going to put the standard deviation. So this example would look like this. 0.10, 500, than 50. Again, a lot faster, and let me show you what that looks like in real life. So, we go here. We go second. We go vars. Go down to number 3, inverse norm. Type in the percentile that we want, comma the average, comma the standard deviation. And look at that. We get something very, very close to what we got when we used the table. So again, the calculator is going to be a little bit more efficient, but you have to practice on it. You can't just, learn it once and then expect to know it on the AP exam. All right, the last thing we're going to cover is finding percentiles in between two numbers. So same situation, but let's say we want to know what percentage of bears fall between 490 and 540. So how would we solve that? So first we'll do it by hand, then we'll do it by calculator, like always. Okay. So we want to know, once again, we're going to start with our normal distribution. With an average of 500, standard deviation of 50. We want to know what percentage of the data falls between 490 and I think it was 540. Let's just double check. And 540. Yep. And 540. So we're trying to find this area right here. So we have to get the z-score. So let's take 490 first. Z equals x minus mu divided by the standard deviation. We're trying to find the z-score, so that's going to remain our variable. We know x is 490 minus our average, which is 500, divided by 50. We're going to get negative 10 divided by 50, which is going to give us negative 2.2, I'm sorry. Now I'm going to go to my z-chart, find negative 0.2 right there. It's about the 42nd percentile. So with the z-score of that is going to give me 0.4207. Now what that means is that 42% of the data falls below. Not what I want. I want what falls in between. The reason we want that is because when we calculate the z-score for 540, that's going to give us everything below. So if I take that percentile, subtract it from 42, what's going to be left is just this area here. So let's go ahead and get the z-score for the bear that weighs 540. So again, z equals x minus mu divided by my standard deviation. Z equals 540 minus minus 500 divided by 50. So z equals 40 over 50, which is going to be 0.8. Now if I go to my z-score chart, this side is all the negatives, which means the data point falls below the average. I want something that falls above the average, so I'm here. I go to 0.8. It's right there. Because remember, 0.80. So 78 or 79, a z-score of, a percentile of 78.81. So again, that's going to cover everything below. Now if I take my second z-score, which is this, subtract it from my first one, which is that, I'll get the area in between. Let's use the calculator just to be sure. 0.7881 minus 0.4207. And there it is. 0.3674. So the percentage of data that falls between a bear who weighs 490 and 540 is going to be about 36 or 37. Oops, 37%. Again, that's great. However, we want to learn how to use our calculator so we can save ourselves a little bit of time. So if we go back here, well, let's just do it here. So we're going to use that normal CDF feature. So second vars, normal CDF. Now remember, normally we type in the low value, the high value, the average, and the standard deviation. We're still going to do that, but this time our low value is going to be 490. Our high value is going to be 540. And our average stays the same, and our standard deviation stays the same. So I'm telling the calculator, hey, in this normal curve that has an average of 500 and a standard deviation of 50, find me the area between 490 and 540. And look at that. We get a number that's almost identical to what we got when we did it by hand. And it took a fraction of the time. That's why, as I've taught AP Stats over the years, I'm strongly encouraging my students to use their calculator because there's less opportunity for you to mess up. Sometimes students struggle with basic math. The calculator does not. But if you prefer to use your probability chart, that's totally fine too. Okay, so let's wrap up a couple things. Where first, this is something you might want to screenshot, right? So if we want to use I'll just wrap up with the calculator stuff. So if you want to compute between two numbers, so the area between two numbers or the percentile, you want to do normal CDF. So it's normal CDF, lower bound, upper bound, average, standard deviation. If you want the tail of the normal distribution, you must use a small lower bound number or a large normal bound number. If you go for standard deviations, that's usually good enough. I like to go negative 99999 or positive 99999 just to be sure. Let's look at an example. If refrigerated milk lasts on average 15 days with a standard deviation of 0.7 days, find the probability that milk lasts A, between 13 and 14 days. And don't forget, we have to assume that the distribution is normal. If it's not normal, we can't do this. So between 13 and 14, well, here's how we would type it in. Normal CDF, 13, comma, 14, comma, 15, comma, 0.7, which gives us about 74% of the data. More than 16, let's say you wanted to know, hey, what's the probability that something falls above 16? Well, in this case, your lower bound is going to be 16. Your upper bound is going to be 9999. So really, really high up. And your average is still the same. Your standard deviation is also the same. And there's your final answer. So about 7% of the data falls above 16% or 16 days. Less than, it's very similar. You use a really small number. You use your upper bound, your average, and then your standard deviation. It looks like I messed up there on the type, had a little typo. That shouldn't be 0.6, that should be 0.7. All right, and the last kind of wrap up for our calculator review is if you wanted to compute, or if you wanted to find the value with a given area under the curve. So let's say you wanted to find out how much data point, or what data point was the 10th percentile. So once again, let's take a look at an example. Well, you always put the percentage, then the average, then the standard deviation. This calculation is the one to use if you know the percentile and you want to find the score associated with it. Super, super important. So here's an example. The scores in a large test are normally distributed. Good. We know it's normal distributed, so we can actually come back and use this. With an average of 74 and a standard deviation of 5. Find the score that represents the 70th percentile. So we would do inverse norm, 0.7, average, standard deviation. So a score of 77.217 would give you the 70th percentile in this distribution. If you want to know the top percentile, so the very top percentile is the 99th percentile. So you go inverse norm, 0.99, 74, standard deviation of 5. Okay, so we will be live every week, all year, plus cram sessions when you really need us in May. So going to these live sessions early will give you the best chance of getting college credit. I wish I had this growing up. Super, super helpful, especially the feature where you can ask questions. So the live sessions are really where it's at, as well as, when you want to review for any tests, those, oops. Let me get that back up. Those review sessions are going to be super helpful as well. Not sure where let's go back. There it went. And not sure why it's not coming up. But all of our live sessions are going to be free in September, but to keep access to the replays and to watch all upcoming sessions, you'll need to join. Until October 1st, we are in our fall early bird special. So it's $15 per subject, $30 for all subjects all year. One-time payment, and it's way cheaper than any other live support that you're gonna get. We literally saved students over $1 million last year in college credits because college in America is so freaking expensive. Click the link below to find out more and join this week. Y'all are on top of things early, so we want to reward you with the price. It's gonna be different in May, so make sure you sign up now. It's $15. What's that, like 1 month of Xbox Live? Yeah, it's gonna be way cheaper than anything. Trust me. I used to do private tutoring. I still do some on the side, but I feel like this is a much better platform to reach more kids and to help more students find a love of AP Stats, pass the class, get the college credit, walk into your freshman year with some credits in your pocket, with some cash in your pocket, so you can go buy those books or hang out, go to a Beyonce show, right? Save your money. AP Stats is where it's at. I will see you next week. Enjoy.